All right, this is for mainly for period 3 and 4, or if you were absent in period 1 yesterday. On the back of the page, we can get into the secant tangents theorem. And I have taken the liberty to combine these two theorems in your book. If you did your homework, it required that you looked up and did a little bit of reading on one page to kind of see these two theorems. That one relates to two secants, like you'll see in these two drawings. You got a pair of secants. So that's the first situation. The other one is when you have a tangent. Now, I don't have any on here. We'll do a tangent on the bottom of this. But one of these could be a tangent, and you have a secant-tangent combination. It's basically the same theorem, so I summed it all into one paragraph, so to speak, or one little theorem. You certainly could break this out and make it two theorems. You can read them in the book. They basically say the same thing that I'm going to say. So here's how a theorem works. Here's the restrictions on it. If a secant and a tangent, or two secants in this case, start from the same point outside the circle, and you know that the outside of the circle means exterior or external. I think your book uses the word exterior. And then they intersect a circle. Then this circle is cutting them proportionally. These four lengths have some sort of proportion on there. And it is a little tricky. It does relate to a product, just like the previous one. So it relates to multiplication. But it's not just the outer times the inner. It's not just outer times the inner. It's the entire length of one of the secants times its exterior part. So, I'm going to throw some letters on here. We're going to do this one just sort of algebraic with nothing to solve for, just sort of writing a formula. It is the entire length, which in this case would be A plus B, times the exterior part. That, whatever that product would be, is equal to the other one. The external part, the C, times C plus D. Again, it's really, if you get these E words into your brain, you'll have this theorem. This theorem is all about external times the entire length for both secants. And we'll talk about the situation where tangent in a minute. Just hold on to that thought. So really, this is sort of your formula. A times the sum of A plus B is equal to C times the sum of C plus D, the entire length times just the outer part. And you'll see if we were to actually do this, you could say maybe we could simplify this. You'd get A squared. Over here you might get C squared plus CD. There will be some quadratics on here. You're going to see a quadratic or two on your quiz coming up on Thursday because of this situation, because of this exact situation. So on the right-hand side, I kind of want to throw one at you, sort of manufactured numbers. This is sort of like the discoveries you did. You could have gotten nice numbers like this on the discovery. And this was a hard one to discover on your own without any direction. I'm glad some of you really tried this and really messed around with the calculator. I saw some papers that had a lot of different calculations. People said, oh, maybe it's a summation of two things. Maybe it's a difference of two things. It's two different things. There's the addition of the exterior and the interior part to get the entire length. So you get 30 here. On the bottom, you get 25. And then the hard part is realizing it's a multiplication relationship. So I just want to verify it with these numbers. So you do 10 times 300, not 10 times 20. And then you do 12 times the entire length. So 12 times 25. So grab a calculator. What is 12 times 25? Or what's a quarter of 25? Sorry, not a quarter of 25. A quarter of 12 times 10. So if you multiply these out and you multiply these out, you get the same thing on both sides. That's sort of my point. You get 300 on both sides. So this is sort of just showing that the numbers would work if you had a measurement situation. We'll throw some algebra in here. So one of these four variables is going to be missing, basically. And I would suggest you try you pause this thing and try the first one, and then pause it and try the second one, and then pause it and try the third one. These three problems all have a little different on here. You'll see we're going to get into the tangents in these two cases later on. So again, I would say try this one on your own. Take 30 seconds, try it on your own, and then hit play and see if you get the right answer. So again, it's external part, 8 times the entire length. So 8 times 28. And then it's going to be 9, not times 9x, but times 9 plus x. It's times the entire length, which is a summation of those two. And of course, here you get 81 plus 9x. And of course, in your head, you know that 8 times 28 is 224. We all know that. And it's easy to solve from there, obviously. This entry into the problem is obviously the most important thing that's on your paper. When you're doing your homework and it says show all your calculations, that means show this. This better be on your paper somewhere. Subtract 81 from both sides, divide by 9, and of course you get 15.88888888888888. And of course you know that 15.888888 is 15 and 8 ninths. You should have some familiarity with your fractions. Repeating decimals, I should say. Like I said, this is a good time to pause, or maybe I'll talk for a second here. This one's a little different. Maybe you listen to me for a second here. It's the same rule we had before. It's the external part times the entire length. But in the case of a tangent, the external length is the entire length. So they're equal to each other. This is x times x. And the secant situation is still the same. It's still 9 times 25 times that entire length on there. But again, this is where quadratics come up. You know, this is going to be x times x, or x squared, and 9 times 25 is 225. And of course, you know your perfect squares. Take the square root, and you know that's positive 15. And negative 15 wouldn't work because the length can't be negative up here. This is a good time to pause. Try this one on your own. It will not be quadratic. It'll be linear. I don't think it's really drawn to scale. You know, this probably should, the secant probably should be down here a little bit, turned maybe. Would be a little more accurate if it was drawn to scale, something like that. But give that one a try. Again, it's the external, 4 times the entire length, x plus 4. And for a tangent, the external is the entire length, so 6 times 6, 36. And of course, you distribute here, you get 4x plus 16. You know, that is the key algebra step on here, is knowing how to distribute, knowing how to set up an equation and distribute, or knowing how to square it in some situations. And of course, this one works out nicely. You end up with x equal to 5. Like I said, not drawn to scale. That clearly does not look shorter than the 6. It's probably some computer problem on there. All right, so here we are on the bottom. I'm going to sort of let you pause this thing, try it on your own. I'll come back in a second.